Hello everyone and welcome back. In this lecture we are going to talk about DynamoDB secondary indexes. Now indexes are nothing but data structures that enable us to perform fast queries on different columns in a table. So once you create an index, the database handles it for us, so you don't have to do it. All the changes in the table are detected and indexes are modified to reflect the changes in the table. In DynamoDB, you need to provide key attributes while creating the index. You must specify a partition key and an optional sort key. You can of course query or scan the indexes just as you would query or scan a table. Now DynamoDB supports two different kind of indexes that you can create. The first one is global secondary indexes. In this one, the primary key of the index can be any two attributes from its table. So you don't have to specify the primary key or the partition key that you specified while creating the table. You can specify the partition key as any other attribute from the table. The other type is local secondary indexes. Now while creating local secondary indexes, the partition key must be the same as the partition key of the table which you specified while creating the table. In fact, local secondary indexes can only be created when you are creating a new table, and you cannot add local secondary indexes later on. Now let's talk more about local secondary indexes. Imagine you have a table as displayed here. It's a simple orders table with order ID, customer ID, amount, and some other attributes like order timestamp. Now as I mentioned, local secondary indexes has the same partition key as the original table, the base table, plus you can add a sort key. Now sort key can be any of the other attributes from the table. You can in fact have multiple different local secondary indexes defined while creating the table with different sort keys. For example, you can define order timestamp as your sort key and your order ID as partition key. Then you can query different orders between two order timestamps. Like if you want to fetch all the orders between two dates, you can do that by defining order timestamp as the sort key in your local secondary index. Similarly, you can have customer ID as your sort key, and you can fetch all the orders by defining a range of customer ID or for a single customer ID. Similarly, you can define amount as your sort key, and you can fetch orders for a range of amount or for a particular amount. So depending on your query pattern in your application, it's up to you to decide what all queries you will be doing and what all different secondary indexes you might need. Now, local secondary indexes cannot be created in an existing table. They need to be created at the time of table creation. Always avoid scanning whole tables in DynamoDB, whether you're using local secondary indexes or global secondary indexes. These are very costly because you're pretty much scanning millions of items, let's say, and then it's going to cost you a lot. So it's always wise to create secondary indexes as per your query patterns and always query the table instead of scanning it. Now while creating the DynamoDB, you need to specify some provisioned throughput. These are nothing but resources that you want to allot to your DynamoDB based on your estimated read and write operations. So local secondary indexes uses the provision throughput that you set for your base table or the original table. So the provision throughput that you set for your base table will be shared between your local secondary indexes and also your table read write operations. Now key attributes, for example in this case the order ID and let's say the order timestamp, will be projected in your query by default. But let's say if you want to add some other attributes along with your fetched data, by default you can add them as projected attributes while creating your table or local secondary indexes. Now, global secondary indexes will again have a partition key and a sort key. But the difference here is the partition key does not need to be same as the partition key that you set for your base table. So for the same orders table, now you can set customer ID as your partition key. Now this particular scenario becomes really important in cases when your application grows and then later on you realize that you need to query for different patterns. For example, later on, let's say you want to query your table by customer ID instead of order ID. Now you cannot change the local secondary indexes because your table is already created. You already have lots of data in table. You will have to create a global secondary index for that. Now, because you're creating the global secondary index later on, you have to assign provision throughput set separately for GSI. So these throughput values that you set for your global secondary index will not be shared between your base table. So this will be additional cost, but you get more flexibility as your application grows, your user base grows, and your query patterns changes. Because this allows you to query your table by non-partition key attribute of your base table. Now GSIs, you can also create them while creating your table. If you want different partition keys at the time of creating your table, you can do that. DynamoDB gives you that flexibility, and you can also create them for an existing table. So in this case, as I said, you can have customer ID as partition key, and then you can have amount or order timestamp or any other attribute in your table as your sort key. Of course, you can add projected non-key attributes. So let's say you're querying your table for customer ID and amount is your sort key. These two columns will be sent back when you do a fetch query. But in addition, if you want order timestamp to be sent back from your table, you can add it to your GSI, and the query will return the other attributes that you set in the projected attribute values. We will see it while creating our first DynamoDB table. This becomes really important because if you do not specify projected attributes while creating your global secondary index, and later on you try to add this projected attribute to your query, you will use up twice the amount of your throughput for querying your indexing and then fetching additional attributes from your table from your original base table. But if you add it to your GSI, your global secondary index will map the projected attributes to the index that you are creating along with your key attribute values.